Here I'm getting my Z transform, sir. Sir, if I take this input sequence and my origin is 2, I'm getting this is result, sir. Sir, excuse me, sir. Is it visible, sir?
Yes, it is visible.
And the second part I tried was the inverse Z transform, sir. Sir, the mod Z is greater than one part and that my 0.5 part I couldn't do, sir, but I found the inverse Z transform, sir.
What was your signal?
So this one was a given example, sir. The equation was the numerator was 1, sir, and the denominator we had 1 minus 1.5 z whole power minus 1 plus 0.5 z whole power minus 2. So for that I got the inverse transform. As residues I got 2 and minus 1, and the poles I got 1 and 0.5, sir.
Okay, but what was the inverse signal?
So the signal was 1 by 1. This part, sir.
You could have print that one here using the
Yes, sir.
poles. Yeah, using the poles and residues.
Yes, sir. I'll keep it. Just
You can, yeah, you can print that input signal.
yes, sir. 1 second. I'll put now, sir. Yes, sir. I did.
See here the array of numerator coefficients. Okay, that is not correct. You have written. It is you have written NUM numerator is 0, 1, 0, but actually what should it be? It would be. It is not correct. You have to write. You have to follow the power of Z. Okay. Either you follow the sequence of uh, z to the power 0, okay, then z to the power uh, that minus 1, like that. But better way is take the ratio, okay, with the power of positive power, that multiplies z square both the side, okay, z square. Then the numerator would be z square by z square, and denominator would be z square minus 1.5z plus 0.5. So that time you will see that coefficients would be 1, 0, 0 in case of numerator, and denominator is 1, 1 minus minus 1.5 and 0.
Yes, sir. I'll do it.
So earlier I have shown the example how to take the numerator, how to write the numerator. So the previous example was what? It is, let me check. Uh, okay, previous example was z by z square. It was there, no? Z by z square kind of thing. Okay, so but you have not written that inverse transform.
Yes, sir. I'll do it now, sir.
and clarify me what should be the actual this inputs, numerator and denominator array.
Sir, is my screen visible?
Yes, screen is visible.
So this is for the Z transform. And I have taken the inputs instead of initializing them from outside, and this is the time domain. And we get the Z transform, sir.
So error is coming.
Yes, sir. 1 minute. Yes, sir. This one is the output for 1, 2, 3, 4 with origin at 2. I mean 2 at the origin, and we get this, sir. And inverse that transform, I was not able to do it, sir. So
why? No, that you have not run.
which, sir? Inverse that transform or?
IZT. So all of you please check how to give the numerator and denominator coefficients in MATLAB. Okay.
Yes,
So
sir. That we can use it from RPK. Using the residue function, we can find out the residue.
Okay, but what I am telling that means suppose one function is given, so in that case there it had some numerator expression and denominator expressions with the power of z. So but that actually is given in MATLAB in the form of array. Okay, so that is actually coefficients of z. So how to give that coefficients of z, that I am telling you.
Yes, sir.
In PPT, okay, PowerPoint file. Have you checked it? PowerPoint file.
Yes, sir.
You see the theoretical solution is there, and you check that one with your MATLAB result.
Yes, sir.
Right now I am opening that file, okay. And also you all of you open it and see what type of results is coming. That z greater than 1. So for that function would be 2 into 1 to the power n un minus 0.5 to the power n un. Is it coming?
Yes, sir. That is only coming, sir.
For 100.
For 010.
010. ROC marginal 2 into 1 to the power n un minus 1 into 0.5 to the power n un. In that case, yeah. So, so this way 010 should be given, or if you apply, if you give the constant 100, okay. So what should be? All of you open, keep your MATLAB opened, and whatever the discussion is going on, according to that you do. And if you have any doubt, you can ask at the same time. So it is delta constant is coming. Yeah, the 2 into 1 to the power n given 2 into 1 to the power n. Now almost the result is that time, it is slightly different. So now I am sharing the screen. Okay, what I am discussing that. So this is your first part is Z transform. Then second part is what? That calculation of inverse Z transform xz is equal to 1 by 1 minus 1.5 Z inverse. Okay, so in the theoretically, how we have calculated that this is the partial fraction expansion. This is the problem. Okay, and the same problem solved theoretically, that mod z greater than 1. So for that, this is would be your signal. So the lower the expression at the bottom is actually your solution. Okay, 2 into 1 to the power n un minus minus 0.5 to the power n un. So these are for the first case. For the another case that is solved in the program, that is case number C, that mod z is greater than 0.5, less than 1. So for that, this will be your signal. Okay, minus, this is your solution. Minus 2 into 1 to the power n u of minus n minus 1, 0.5 to the power n un, 0.5 to the power n un. So if you run the MATLAB program for this, okay, keeping 0, 1, 0, okay, 0, 1, 0, okay, so it would be now I'm running that program, and output is this one. For case 1, our ROC mod z greater than 1. Okay, the inverse Z transform for ROC mod Z greater than 1 is this: 2 into 1 to the power n un minus 1 into 0.5 to the power n un. And inverse Z transform for the another case, that ROC is greater than 0.5 and less than 1. ROC, that is, what is the theoretical calculation? That minus 2 into 1 to the power n u of minus n minus 1. Okay, so minus 2 into 1 to the power n u minus n minus 1 minus 1 into 0.5 to the power n un. Okay. So it is matching with this one. Okay, but here the important thing is that the coefficients for numerator and denominator have to be properly written. Okay, so you can see both numerator and denominator is written as 0, 1, 0. Okay, that Harshvardhan earlier showing it was correct. Okay. So actually, in partial fraction, we express in the form of xz by z, isn't it? Xz by z. So if you multiply z square in both numerator and denominator, in numerator it will be z square only, because in numerator only 1 is there. But you have to represent in terms of xz by z. So that power of numerator will be uh, uh, reduced by 1. So earlier it was z square, now it will be z. So if that is the case, then you have to, the numerator coefficients array would be 0, 1, 0, because z square term is absent, so its coefficient is 0. Then z, the coefficient of z is 1 and the constant is 0. So we are writing as 1 minus, and in the denominator also the coefficients with the power of z square, it is 1 minus 1.5 and that way. Okay. So is it clear? Are you following?
Yes, sir.
Okay. So now we are going to the second part of the experiment, that is stability. Okay. So how to find how what is the definition of stability? Can anybody tell? What is the definition of stability?
Sir, the function should be of bounded input and the output also should be bounded. Then
Yes.
it is stable.
Yes. And in another, in terms of impulse response, can you define stability? In terms of impulse response, or in terms of the that poles. Okay, can you tell?
Sir, ROC should be outside unit circle if for A is negative for a non-casual sequence, sir.
क्या बोल रहे हो?
सर नॉन कैजुअल सिग्नल के लिए हमारे पास ROC अगर इन आउटसाइड यूनिट सर्कल है सर तो सिग्नल स्टेबल रहेगा, नहीं तो सिग्नल अनस्टेबल रहेगा.
So for causal sequence, what should be the conditions for stability?
Sir, if ROC includes unit circle, then the signal is stable.
ROC include unit circle. The signal is stable. And
Sir, ROC should lie outside the unit circle.
okay. Any other method in terms of poles?
And then it is stable system.
Left up of
S plane.
S plane. So are we talking about S plane? Which plane we are talking about?
Sorry, Z plane, sir,
Z plane. So in Z plane we have to focus on unit circle. Okay. Unit circle that should be considered. So poles actually if the poles are within having the value less than 1, okay, so in that case the system is stable, and if provided that it is causal, okay, if it is causal, then the pole should lie inside the unit circle. Okay. Why so? Because say one example we take, that signal is xn, okay, xn is equal to 1, the transfer function xz is equal to 1 upon 1 minus az inverse, okay, and say it is causal, okay, xz is 1 upon 1 minus az inverse, and it is said that signal is causal. So what should be the ROC? Can anybody tell? What should be the ROC? Harshvardhan?
Sir, 1 second, can you say the question, sir? It was not clear.
The Z transform is 1 upon 1 minus AZ inverse. And it is said that the sequence Xn is causal. Okay. So what should be the ROC?
Sir, 1 second. Sir, the mod Z should be less than A.
Mod Z less than A for
Yes, sir.
causal sequence.
No, sir, sorry, sir. Mod Z should be greater than A. For non-casual, the mod Z will be less than A.
Or not non-causal, anti-causal. Okay. So mod Z is greater than A, it is the ROC. So if the value of A is, now say if your Z transform is 1 by 1 minus AZ inverse, the same J form expression. So what should be the time domain sequence? What should be the time domain sequence?
Sir, U of N.
No. In
No, sir,
terms
sorry,
of,
A power N into U of N.
yes, A power n of U of n, because it is causal sequence. Now question is, what value of A should be? It is greater than A or less than A for stability?
Sir, sir, mod Z greater than A.
Mod Z greater than A. That is ROC you are telling. Okay, that is region of convergence. But I am asking, what will be the value of A? A का value कितना होगा? A to the power n un. That is your time domain sequence. But for stability, A का वैल्यू कितना होना चाहिए? 1 से ज्यादा होगा कि कम होना चाहिए?
सर 1 से ज्यादा होना चाहिए.
1 से ज्यादा होना चाहिए. सब लोग यही बोलना चाह रहे हो?
नो सर 1 से कम होना चाहिए.
1 से कम होना चाहिए सर.
यस, 1 से कम होना चाहिए. जैसे जैसे n बढ़ेगा आगे, n is equal to 1, 2, 3, 4 like that, a का पावर n है, तो a अगर 1 से ज्यादा है तो वो इंक्रीजिंग हो जाएगा सिग्नल, okay, increasing sequence. And when n is very large, that time that function value would be very, very high. So your input would be not bounded. Okay, not bounded input. It will be unbounded input. And also it is not summable. If you consider the concept of stability, that is impulse response should be summable. मतलब उसको ऐड करके कुछ फाइनाइट मिल सकता है, लेकिन इस तरह का सीक्वेंस अगर है, ग्रोइंग सीक्वेंस, इंक्रीजिंग सीक्वेंस, इसको ऐड करोगे तो वो बहुत इनफाइनाइट वैल्यू हो जाएगा, सो इट विल नॉट बी स्टेबल. सो ए का वैल्यू 1 से कम होना चाहिए और कॉजल सीक्वेंस के लिए. तो तुमको एक प्रोग्राम लिखना है फॉर कॉजल सीक्वेंस to check the stability. Okay, so one expression will be given and you have to check the stability of the system. So what you will do, you have to first find the poles. Okay, poles of the system. Poles is what? In this example that I have taken 1 upon 1 minus AZ inverse. What is the pole in this case? 1 upon 1 minus AZ inverse. इसमें पोल कौन सा है? What is the value of pole?
Z equals A.
Z equals to, पूरा बताओ, सुनाई नहीं दिया.
Z equals to A.
Yes, Z is equal to A. So if that value of A, that means if the value of pole is less than 1 and at the same time the system is causal, then you will tell that this system is stable. Clear? Otherwise it would be unstable. ये अगर पहले चेक करना है whether it is causal or not. अगर causal है तो you implement the condition that if the poles is less than 1, then you will definitely tell that it is causal system. If it is causal but pole is more than 1, then you will tell that it is not causal, it is not stable, unstable system. ये एक पार्ट है, ये एक केस है कॉजल सिस्टम के लिए जो अभी हम एक्सप्लेन किए कि पोल का वैल्यू 1 से कम होना चाहिए कॉजल सिस्टम के लिए, और 1 से अगर कम है सो मॉड जेड क्या होगा. मान लो 1 से कम है पोल का वैल्यू 0.5 है, से 0.5, so mod z will also be, that is ROC will also be greater than 0.5 the region, and that includes the unit circle 1. That is also coming from the same concept that ROC includes the unit circle or causal sequence. But in the MATLAB program you have to check the value of poles, whether it is less than 1 or greater than 1. If it is less than 1, then it is stable. If it is greater than 1, it is not stable, provided the whole system should be causal system. Okay, this is part for causal system. Now I am coming to anti-causal system. Anti-causal system, suppose we take the same example, that is 1 by 1 minus AZ inverse. same example, but it will represent anti-causal. So what would be the time domain sequence? Can anybody tell?
Sir, minus a power n into u power u into minus n minus 1.
Yes, minus a to the power n u of minus n minus 1. The same jet transform, but the time domain sequence is lying in the left side, this negative time axis. Okay. That is anti-causal sequence. Anti-causal sequence. Okay. Now first coming back to the ROC. What should be the ROC for that? Region of convergence for that?
Sir, it should be inside the unit circle.
Mod Z is less than A or greater than A?
Sir, less than a.
Mod Z is less than A. That is interior, don't tell unit circle now. You must tell that interior of a circle in case of anti-causal and exterior of a circle in case of causal. And which circle? Circle of radius A. Okay, circle of radius A, which is actually the pole. A is what? It is a pole. Clear? So ROC is interior of a circle in case of anti-causal sequence of radius A. Circle of radius A. Now coming back, this is the condition for causality, whether it is causal or anti-causal. You can determine it from the ROC given. Whenever Z transform is provided, it is provided with ROC condition. Now, coming back to the condition of stability. Okay, stability is what? For anti-causal system, what should be the stability? Can anybody tell?
Greater than 1, less than 1.
Greater than 1 or less than 1?
Sir, poles must be less than a. Less
Poles,
than 1.
poles should be less than 1. That is the same condition is for same as in the case of causal system. Pole is less than 1. Is it correct? Now, if it is so, okay, then you have to verify your assumption by seeing the formula, that is inverse Z transform of the same formula. So we have considered same Z transform 1 by 1 minus AZ inverse. For time domain signal, it is minus a to the power n u of minus n minus 1. Okay. Forget about u of minus n minus 1. It is 1 for all the negative values of n. So it is only minus a to the power n, say. Okay. Minus a to the power n. Now, if a is less than 1, okay, and n is negative, n is negative in all the cases because it is anti-causal. So, say for example, n is equal to minus 1. N is equal to minus 1. So first value of the sequence is what? 1, first value of a to the power n. A to the power n is there. Okay, so a to the power n. So actually n is -1. So it is 1 by a, first sequence. Okay, first value of the sequence. The next value of the sequence would be what? For n is equal to -2, what should be the value? First value is 1 by a, isn't it? N is -1. First value of the sequence, I am ignoring the negative magnitude. Okay, just first value is a to the power n. N is -1. First value is 1 by a. Second value क्या होगा? शशांक?
1 by a square.
Yes.
Sir, 1 by a square.
Yes, yes. 1 by a square. Then 1 by a cube. Now impose the condition that you have assumed. You imagine that a is less than 1. If such is the, if that is the sequence 1 by a, 1 by a square, 1 by a cube. So if a is less than 1, उसका value क्या होगा? Increasing or decreasing?
Increasing, sir.
Increasing. A is less than 1, so each time its denominator is decreasing. A is less than 1. Each time its denominator is decreasing, means overall it is increasing. Okay? So it would be stable or unstable?
Sir, unstable.
Unstable. So what should be the condition?
Sir, poles must be greater than 1.
Yes. Poles must be greater than 1. In case of what sequence?
Anti-causal sequence.
Anti-causal sequence, correct. So now you have understood, I hope, the how to check the stability.